All right, here we go. We're still working on that solving polynomials, determining solutions to our equations. We'll eventually get to inequalities. Our inequalities seem to have a thing. They follow after we solve the equations. We use a very similar technique for inequalities. So we've got to still work through how to find all of our zeros. That means all of our intercepts. That means all of our roots. We're trying to find out all of the x values that solve our polynomial equations. So let's go ahead. I've got 4 examples for us with this one. All right, the first one's a little bit of a review. It's still using that factor and remainder theorem and synthetic division. So we're still going to ask the question, is the second factor, or is the second polynomial a factor of the first? So this is when we use synthetic division for k equals -3, because we get that when we set this equal to 0. So we say when k equals 3 is f of -3 equal to 0. So is it when we substitute it in that we get a remainder of 0? And that's when we use synthetic division. So that's our plan. So we go through -3. We use our coefficients. I am missing a term here. So I have -2 and 1, 0, and -63. And let's proceed. So I drop this one down and multiply, and I get 6, and I multiply, and I get 7, and I multiply, and I get -21. When we add, I said add here, I meant -21. When we multiply, we get a positive 63, which gives me a remainder of 0. So it is in fact that x plus 3 is a factor of -2x cubed plus x squared minus 63. And my explanation, if I needed to justify this, would be because we found that f of -3 equals 0, that the remainder using synthetic division is 0. And that is our factor theorem combined with our remainder theorem, that when the remainder is 0, it is a factor. All right, let's move on. So this one is asking us to not just determine if something's a factor, but then to continue and find all of the factors. Let's see how that would work. So if I know that -3 is a 0, they've already determined that k equals -3 will produce a 0. Okay, then I need to use what's left over. So the plan is to use the leftovers to find the other factors. Let's see how that's going to work. So they've already convinced me that -3 is a factor, which means that my remainder better be 0 or I did something wrong, because they're telling me it works. So I'm going to go ahead and add this down and multiply, and add and multiply, and then I'm going to go ahead and multiply again, and we add and we get the 0. Awesome. So what's left over here, and you can remember this from actually doing division, that the result of this is 6x squared plus x minus 1. So this is not necessarily the simplest form, because they want me to put it into linear factors. So one of my linear factors is x plus 3, and that came from the given information. But then I've got this 6x squared plus x minus 1, and I have to determine if I can continue to factor that down to linear factors. So I'm going to use the factor Punnett square that I've been using all semester, and I put the -1 here. So that's -6x squared, and I'm going to use, my goal here is to get a +1, so I'm going to use positive 3x and a -2x. And then I'm going to factor this into linear terms. 3x here, a 2x here, a 1, and a -1. That means that x plus 3, and then 3x minus 1, and 2x minus 1. I have no idea why the pen just got thinner. So these are my 3 linear terms. Some of you are going to want to multiply it back out. Please resist the temptation to multiply that back out. if you multiply it back out, you will end up here, which is a good thing to check your work. But remember, the goal was to factor. Oops, got excited. The goal was to factor. So if you multiply it back out, you have undone all of the beautiful work that you intended to do. Please leave it here. That's the plan. We got another example here. All right, again, I'm given one of my zeros and it asks me to find the other zeros. So this time, I'm not looking for factors as my answers. My goal is to find the zeros. So that's a really important thing. I'm going to flip back here. This one asked me to factor. So here I got to factor and stop. This one wants the zeros. Find the others. So after I factor, I have one more step. It's really important that you're listening to the directions so that you can follow through correctly. So I know -3 is one of the zeros, so let's get that through. A 1, a 3, a -4, and a -12. And we'll go ahead and use our synthetic division. And sure enough, it did work out. And the result is, well, if this was cubic, then this is quadratic, plus 0x minus 4. We don't even need to write that 0x. But it asked me to find the other zeros, not just factor it. If I was asked to factor, the answers would be x plus 3, that one came from here, and maybe if you did this in factored form, x minus 2 and x plus 2. But the question asks for the zeros. So my zeros are x equals -3, x equals 2, and x equals -2. This is the answer to the question that was asked. All right, I got one last one for us. Let's give it a shot. Same idea, we're going to use the -2 into our polynomial, 1, -5, 11, and -10. We'll drop it down and we get a 2, we add, we multiply, we add, we multiply, and yes, we got the 0 because they told us it was going to give us a 0, which means that this gives me, if I remember my goal is to find the zeros, 2 is one of them. Let's find the others. Well, I have x squared minus 3x plus 5. And I could try to factor this, but I'm feeling pretty confident that there's no way that I'm going to come up with some numbers that are going to give me a 3 in the middle. So I can say that this actually doesn't factor anymore. But the goal wasn't to factor. The goal was to find the zeros. So I have to think about this in another way. What other ways can I solve for x? That is, I have to use the quadratic formula. It's my only other way for this particular situation. So I have 3 plus or minus the square root of -3 squared minus 4 times 1 times 5 all over 2 times 1. That gives me 3 plus or minus the square root of 9 minus 20 all over 2, or 3 plus or minus I root 11 all over 2. So these are my other zeros that would go in my list. So remember, when they're asking for zeros, you have to find whatever method it takes to solve the equation down to the final x values. All right, really great job today.